So as it is visible that we have been provided with an array which is already in a sorted order. That's the first condition that we need to keep in mind while implementing a binary search, that the array should always be in sorted order. If it is not in sorted order, we have to first convert it into a sorted order and then only we can implement the binary search, or else this function will not be working properly. So the first step that we can see that it's in sorted order, so we will just initialize two variables, that is the starting value, that is keeping the note of where my array is currently starting, and another one is the end, it will be keeping where the array is currently ending. So the basic phenomenon here is we will be doing research only in a single half of the array. So for example, as we can see that we have been asked to search whether 0 is present in this array or not. So once we have got this, we will start with a while loop. So we will be having our first condition, that is checking whether our a is always lesser than equal to b, that is our starting index should always be lesser than the ending index. It's very logical that we don't want our start to go after end. So after we get this, now we can see that yes, the starting index is 0 and my ending index is 6, so this condition holds true. So now we have to check next thing, that we have to calculate the middle value, the middle index. So for calculating the middle index, we will basically use this basic formula, that is mid will be equal to a plus b by 2. Okay, so in the first step our middle value comes out to be 0 plus 6 by 2, that is 3. So this our middle variable will be pointing at this position only. So we have the middle value here. Now we will be going to check the condition. So our first condition, if condition, will be to check if our array mid element is lesser than the value to be searched. Let's say it's variable k. We will just say k. Is ARR of mid is lesser than k? Is it coming out to be true? So let's check that ARR of k is currently ARR of mid is currently 3, and we have to check if 3 is lesser than 0. That is not true. So we will go to our second if condition, that is ARR of mid is greater than k. As we can see that 0 is present in this half of the array, so we need to eliminate this part. We have to eliminate this part of the array. So for doing that, we need to pull up our index, last index only, that is b. So as this becomes 2, that is 3 is greater than 0, so we will changing the last index, and we will be doing here that b should be equal to mid minus 1. That's the simple logic. So what we can see that our mid value has changed now along with my value b. So my b value is mid minus 1, so this is the new b that we get. So we can see that yes, this is again true. So we will go to calculate the mid. Now here again our mid value has changed, so this will be 0 plus 2 by 2, which is nothing but 1. So our mid value is 1. So when our mid value is 1, so it will be pointing till here. Once we get a mid value of 1, so again we will come here and check if ARR of mid, that is 0. Sorry, ARR of mid has come and changed to 1. So ARR of 1, whether my 1 ARR of 1 is -1 is lesser than 0. This is true, so we have to we can see that now our search should be in my second half of the array. Now currently my my array lies from here to here, so now we can see that our 0 is present in the second half of the array only. So as a result we need to change our a. So what we will do, we will be changing our a will be changed to mid plus 1. So now our a is changed. So this was the mid, so our a now has been become equal to b. So this is our a. Again, after doing this, we return back to our while loop condition and check if a is lesser than equal to b. Yes, a is equal to b. So again we need to calculate our mid value. So now the mid value will be a plus b by 2, which is nothing but 2 only, because a and b both are 2. So this is a, b and mid have become equal now. So if ARR of mid, that is 0, ARR of mid is currently 0. So let me just move it here and write it, and whether 0 is lesser than 0, no. If 0 is greater than 0, no. So what we have to do now, we have the third condition, that is the ARR of mid is equal to my k value. If this is true, then I will be returning true. So 0 is equal to 0. This is the only condition that is true, and we just return true, and here is when our the iteration stops. So this is how iteratively we can use and implement the binary search. So in this case, the benefit of using a binary search over a linear search is, in linear search what we do is we search linearly, and as a result we have a time complexity issue there. So in linear search our time complexity was O of n, but while we use a binary search we get our time complexity of O of log n. So this O of log n is much better than O of n when our array size is very long. If our array size is very long and the number to be searched is present at the last position of the array, in that case our binary search will take only O of log n time, whereas O of n time will be doing for taken for doing a linear search. So this is the reason we use O of log n. And the space complexity, because we have done it iteratively and we have not used any the recursive function method, so in this case we have a space complexity of O of 1. If we had followed a recursive method, then this would have changed and we would not get a space complexity O of 1. For best case condition, when we say, for example, say if we had to search an element which was exactly at the middle position of the array, in that case we would have got a time complexity of O of 1 only, because as soon as we find this value, mid value, we get a match and we would have returned true. So for the best case it would have been O of 1. So this is how the binary search algorithm works. So let's go and see the code now. So here is the implementation of the binary search. So we have been given the array in ARR. This is k is the element that is to be searched, and we have been given the size. So we initialize our starting index with 0, We then go for initializing our ending index, that is size -1, because as you can see we always start from 0 in arrays, and we have a variable mid. So we check the first condition, that is a is lesser than equal to b, that is the starting index is lesser than equal to my ending index. After that we go for finding the mid value. Once the mid value is calculated, we come to the conditions. These are the three conditions where we check whether the mid value is lesser than k. If that's true, then we move our starting index to mid plus 1. If that is mid value is greater than the element to be searched, then we just reduce our mid value, as we discussed in the implementation while we were seeing this. And the third condition, if its mid is equal to k, as this is the only condition that is possible now, so I have just used a single else statement without using any else if, and I have just returned true. And if all these things it does not hold true, it will just come outside the while loop after the a is lesser than equal to b becomes false, and it will be returning false, that whether the element is not present in the array. This is how the implementation in code in C++ will take place.